Hello Internet! Welcome back to our high scores in Unity series. This is sort of the part where we still figure out everything that we don't know. I'm hoping to get done updating or posting new high scores and then also removing high scores. So we're going to implement... Where'd my mouse go? The heck? There it is. All right. Cool. Well, hopefully nothing else breaks, but we're going to implement either a post or a put and then a delete. And so when we're talking about REST APIs, that's sort of what this is. You're taking an object, in this case high scores, and we're doing specific operations on them. We're either able to get high scores, or we're able to post new high scores or put new high scores into that database, and then we can also delete them. And so there's a difference really between the put and the post. Like really you can implement any of these however you want. But there is a spec for how all of this works, and I don't remember it. The thing that I usually try to remember is that puts are intended to be idempotent, which means that you should be able to run them multiple times and get the same result. Whereas a post is something where if you were to run it multiple times, you would get a different result. So if we were to like post a video, for example, like if I were to use post to post this video, if I were to run that multiple times, I would get multiple videos uploaded effectively. But if I were to use a put, the expectation would be that I would be effectively updating or replacing the same image or same video over and over again. And so in this case, if we want to have a high score where you can just update the same thing and say have one high score per player, you might want to use a put and do it by ID. Whereas if you want to track every high score by a player, you may want to use a post. I think that's sort of the best way I can describe this. And so really this choice is not one that like I can really tell you what makes sense. Because it's something that if you're doing this, you're going to need to choose what you're going to do. I'm going to do a put though. That's just what we're going to do. So we have us to kind of refresh. We have a dictionary here that's keyed off of strings, which are the usernames of the accounts, and then an int, which is the score. And so we're going to do the same thing. We're going to have a string of the ID, and then from the body of our put, we're going to publish an integer value. And so this is effectively just our key value pair. To kind of refresh where we are, let's do, I need to go into one further directory. Sorry, my prompt is bad. But if we do this, we get there. And so we can do .NET. I'm going to use watch here. And so that's going to actually watch this directory and check for any changes. And so as we update our code, I'm not going to need to recompile. It's going to detect those and recompile for me, and just kind of keep my project up to date and continue to host the server throughout that. It makes it a little bit easier to kind of iterate on things. So this is Postman. This is just a basic way to kind of interact with your API. We have 2 endpoints right now, and I've added both of them. We can get a specific high score. So this is the high score for World of Zero. So if we were to go in here, that is the wrong project. But we would see that it has a score of 42. We're hard coding this right now because we haven't done this adding and deleting yet, but it has a score of 42. And then if we go back and look, we got 42 back. Might be a little bit hard to see. Sure, that might be a little bit better. And then if we want to get all the high scores, we also have this endpoint, which doesn't take an ID and just returns a list of the ordered high scores. I think it's the first 100 or 1,000 or something like that. It doesn't particularly matter in this case. We just have an endpoint for getting all the high scores. And so that's what this is doing. And so what we need to do is stick something in this list, which should be relatively easy. We're going to do this the wrong way first, and then we're going to figure out how to make this a little bit better, because this is going to cause a lot of issues for you if you actually try this and then give this to people. Because effectively what I'm doing is just creating a way for us to put any value into this database table. Okay, good. It recompiled. Everything looks good. And so now I should be able to call a put and make it work. So we're just going to copy that, do a put, and put user Highscore. I try to keep this up to date, but and then we set it to go into the body, which I don't. Here we go. Body. We want to include raw, and we should just be doing text, I believe, because we're just including a random value. So we're updating a Highscore with an ID. And so in order to do that, we have to do it like we were getting the specific user. So in this case, I'm going to upload one for C#. Why not? We'll give it a score of 100. And so if I send this out, the input was not valid. Why not? Form data, no. I was pretty sure this was correct, but it might not have been. Okay, this is weird. So going back to this, what this is supposed to do, that it's clearly not doing, is give a ID. That should be part of our URL parameter, like we have it. So just add a slash and then add whatever the object is, the name of that object. And then from our body, we're just providing an integer value. I'm clearly not doing that part right though. And so there's a few different ways that might be expecting this by default. I kind of just threw text at it and kind of hope that that would work. I don't think this is going to do anything either. Okay, formatting it as JSON, sure. So the reason that worked and the previous one didn't is ASP.NET in pretty much every other web server you're going to use is going to have an expected formatting. So if we actually look at what we're sending, we're not just sending this data and then that body data. We're sending a bunch of headers as well that's going to have metadata about this message that we're sending. So it's, if you think of an envelope, there's a bunch of stuff on that envelope that's saying where it came from, who it's to, and like if it's been through like customs or anything like that. It's going to have all that extra stuff. We do the same thing when we're sending things with a computer, except we label like what kind of data type is it so that people know how to read it. Like you need to know what language your message is in so that everybody else can understand it. And so in this case, we're declaring that it's application JSON. If I go back here and change this to text, we should see this change to text plain. And so what ends up happening is, that's not right. But what ends up happening is ASP.NET has a specific response type or format that it's looking for. And we weren't giving it that. And so it got very confused and said no. But we can give it this and then it should work. I didn't check if we had already added something. So if I try to do this again, we get an internal server error because I just broke everything. Because I tried to insert 2 of the same key into a dictionary. So with the way we've done this, there isn't actually any way for us to upload 2 of the same score because it's keyed off of the name of the player and each player can only have 1 value. And so if we try to add another one, everything explodes. And so what we need to do is do a little bit more checking here. This still isn't going to be perfectly safe, but it's going to be a little bit better. And while we're here, we should be able to get Highscores. And if I do this now, we don't see it. That's going to make everything a little bit harder. But the reason we don't see it is because it gets recreated. There it is. Okay. I think that was the error. So I should go a little bit into the magic of ASP.NET. This controller class here, every single time we call this controller, you get a new version of this controller. There isn't one instance of this class that exists and just magically does everything for you. There's one, but it gets recreated every single time you call it. So every time we're calling that put, we are calling the constructor for this, and we're recreating this. And so what can end up happening is, if this isn't a static type, you can end up dropping your data. Because if we make this a non-static type, it doesn't persist between them. And so every time we would recreate it, and then it would get deleted after the call, then you'd call it again and then get recreated, modified, and then dropped again. And you'd just be in this endless loop. This isn't really a database in any sense of the word anyway, but that's sort of how this ends up working. So we get this here, and it'll be there until we either like change code or do something else bad. But there we go. There's our C# value. And so the next thing we need to do is actually test this. And so what we want to do is see if Highscores that has contains key. There we go. It's been a while since I've worked with dictionaries in C#, so we'll figure this out. But if it doesn't contain the key, we can just add our value, right? Because it's not there, so let's just add it and call that good. Otherwise, it may exist. So otherwise, we need to do something. And so our current Highscore is going to be what we're going to actually pull out of this, and do current value equal Highscores of our ID. And so we can just index into this dictionary and pull out the current user's Highscore and see what that is. And then what we want to do is do Highscores dot, I don't think there's an update, or replace. So we can just remove that ID and then do a Highscores dot add. Unless append does what it appends a value to the end of the sequence, that's not what we want. So we're going to just add it here. And so if we give it an ID, and then we want to do a math.max and take it's a Highscores list, right? So we're going to take the highest value of the two that we have. So we have value, which is the value we just uploaded, but we also have the previous value. And so if our previous value is higher than the last value, we don't want to override the Highscore with something lower. And so that's what this is going to be checking for. And then at the end of all of this, we should be good, right? So we've tested against the current Highscore. We've removed that value, and then we've added back whatever the thing is. We have to have this remove here because if we try to add on top, we're going to run into collisions because we tried to add something that already exists. And so with dictionaries, you can only have one ID. Otherwise, everything gets really mad and it explodes. So there is all of our insertions. And so if we look at this, we recompiled, so we lost all of our value. Because I have that watch running in the background, every time I change code, we're regenerating and relaunching this, which means all of those static values that I've done, they get lost. Because we don't have any persistent storage or anything, every value that I'm writing into memory gets reset every time we're recompiling. That's why these keep going away. And that's why we lost our last value. And so we can post it again. And let's just add like Java as well. Let's make it something lower. 99. And so now we have two additional values. We have C# and Java, and they're added in the correct places. And then if we go and try to like change Java to say 70 and run this again, we get an OK response. We might want to change that. But if I run this again, it's still at 99. So we didn't actually modify anything. But if I go and set this to like 120, then we should see it jump ahead of C# up to 120. And so now Java's at 120, C# at 100, and that's clearly not right. So we'll set this to like 150. And there we go. And so this is just a really quick way to kind of modify things. There's still some less nice things that are happening here. It shouldn't be too big of an issue right now, but typically taking random data that people are just throwing at you and injecting it into databases is a really, really bad idea. And that's exactly what we're doing here. And we probably want to not do that. And so in this case, the problem is not so much here, but if we were storing this in, say, SQL, for example, or in this case, if we were doing something more with this code and putting it in a place where it could potentially be executed, like the thing with SQL is you would write like a select statement or something and try to select by a specific username. In that case, if you're trying to select by a specific username and that username is like drop tables Highscores, every high score just got deleted because they just owned your database. And so in order to prevent that, you can do encoding things, and to kind of get around that, I'm not doing that here. And so that's something to be very considerate about, is like SQL injection, and those kind of attacks are something that can be very easy to do, and people will just do it to troll. And so as we move forward, as we actually start getting into database stuff, that's something we're going to be looking at, is how to actually not do this, and prevent that from happening. But I want to bring it up here because you might skip ahead and start doing that. And so it's something you should be aware of, because otherwise you'll figure it out when people are like, where is all of my data? And it went away because somebody wrote that command. And it's not just like drop tables that they could do. If you're storing like sensitive information, it would be possible for them to say, write the entire contents of your database into their username and then grab that username or something, and end up like pulling some of that information out. There's a number of different things they could do. So we're gonna keep that in mind, and we're gonna move on. But yeah, that's something to consider. Let's move to the delete though. And so the delete is similar, and really we're doing the same thing. If Highscores dot contains key of the ID. So if the ID exists, then Highscores dot remove the ID, and that will remove the ID if it exists. It's a string. We need this to be a string because our database is keyed on strings. That might not be a good idea either, but we're doing it. So there we go. So this will remove the ID if it exists. This also has problems. We don't have authentication or authorization or anything like that in this scenario, which means anybody can delete anybody's high score. So maybe your friend got a better high score than you. You could just go in and delete theirs. We probably don't want that, but we're not dealing with that at this point, because dealing with that is actually kind of a more complicated issue than this. So we're going to ignore it. And so now that we have all of this, we should be able to actually do most of this like basic operations, the absolute basic stuff of how this works. It's not super secure. It's not something that you'd want to actually deploy anywhere and let people use. But it will give you a way to kind of, at least the basics, start doing this stuff. And from here, we should be able to kind of get rid of this dictionary that we have just floating around and actually start offloading that into either a database or something more persistent than a static variable. Because even if we're not relaunching it every time we change code, whenever our website would go down or we'd restart our computer, we would lose all the data. And that happens regardless of where you're running your computer. So that's something to keep in mind. So anyway, we have all of this. And so it should all come and be figured out. I don't know what I was going to say there, but I'm sure it was very smart. And so let's create this delete user high score. Like that. And so we have a way to delete all of our high scores. There isn't actually a username attached to this, so let's attach one and do like world of 0. And you'll notice as I'm typing this out, it has suggestions. And the reason is because the only thing that's different between this delete and this put and this get is the verb here. We're either getting or we're putting or we're deleting things. But the actual path for one user will be the same for all of this. And so that's like the big like thing, I guess, with REST. And so in this case, we can delete world of 0 and it should go away. And so now we should see Minecraft and Halo, and the rest of these should go away. C# and Java are going away because we recompiled. And so we lost those values that we added. World of 0, we're losing because we just deleted it. And so we should see 2 things. And then if we want to delete Minecraft, we could do that and delete Halo as well. And then everything should be gone. And now we just have this empty list, which pretty much is where you would start normally if you were actually not initializing your list. But we can start adding things here and actually put C# in, and we can actually start building this back up. And so that is like basics, I guess, of the service side of this. The next step is going to be probably adding a database onto this. I haven't really decided what database I want to use. There's a lot of different ways we can store high scores, and there's a lot of different things you can tell from where you store this. And so some ideas are like a Postgres or SQL type database where we can just have tables of this data and kind of just collect the high scores in effectively a table just like we had here, just not there. Another option is to put it into something like a time series database. And so those are not going to necessarily give you this level of detail, but the handy thing for this is you can track changes over time. And so in this case, you wouldn't necessarily be tracking data or high scores by user. You would be tracking it as a set of instances or occurrences over time. And so if you were trying to track points, for example, you could get the sum of the total amount of points that had been scored over any amount of time. And it gives you really nice ways to do that. And there's some nice data like dashboards and things that can be created around that. But it makes it less easy to actually do this. It's more useful for metrics and things. And so that could be a handy way to like track how things are going, not only as like active users on your game, but also as like how many people have completed level 1 or level 2 or level 3, or how many like minions have the players slain, or how many coins have they collected, or things like that. That would be a really handy case for that, because if you try to store that in like a normal database, it's going to get really big and the queries are going to be really slow. And so that's one of the things like a time series database is useful for. There's a few others that I don't think make a lot of sense, but maybe somebody else has one, like an event queue, like Kafka, which allows you to store events, where in this case it would be like a high score into a queue, and then you can attach other things onto the back of that that would consume it. I'm not entirely sure what you would use that for, but it's like a third option, I guess. So if somebody has a preference, leave it in the comments and we can take a look. I'm probably leaning towards the SQL because I feel like 95% of people just want a high score table, but the other ones might be interesting as well, and we'll probably end up doing those anyway. But just if you have a preference for them, it could take a while to get to like the weirder ones if nobody's asking for them. That'll just be when I'm feeling in a quirky mood, I guess. So yeah, I guess that's mostly it. It's not too much code here. Most of it fits on like a screen, I guess. But for the most part, it's just figuring out what these functions are and how to call them. I personally find Postman really handy for that. You can find other tools that will do this. Even some web browsers now are letting you do that or have things integrated into them. I think even Visual Studio Code has some way to invoke requests like this. And so yeah, that's it. After we do this, we have to do the database. And then after we get the database, we have to actually plug it into Unity and actually make this do something useful instead of just be a random like proof of concept thing. So yeah, that's it for now. And thanks for tuning in, and I will see you in the next video. So until then, see you, Internet.